Dear Outrun the Sun team, supporters and friends. My name is Posch. I'm the 2014 Outrun the Sun research scholar. And back in 2014, I've been studying the role of PD-1 on tumor cells together with another Outrun the Sun research scholar, Professor Tobias Schatton at Harvard University. PD-1 is a so-called immune checkpoint molecule, and one can think of it as like a negative regulator that puts a brake on immune cell activity after their job is completed. You can imagine that this regulation is critical for everybody, otherwise we would live in a state of permanent inflammation, and that would obviously be a bad thing. The problem is, however, that tumor cells are able to use this mechanism to hide from immune cells. And that is critical because the job of immune cells is not only to clear our bodies from infections and pathogens, but also from tumor cells. So if a tumor cell is able to escape immune surveillance, it gives them a survival advantage. In our research, we were able to show that this important immune checkpoint molecule, PD-1, can be found not only on immune cells, but also on tumor cells. This was quite controversial at the time, because it was believed that immune checkpoint molecules are only to be found on immune cells. Today we know that PD-1 has an important role on tumor cells too, and targeting this receptor can contribute to help improve melanoma treatment. In 2015, we were able to publish our findings in the prestigious journal Cell, and I'm very happy to send anyone a copy if you want to read a little more about it. Your support helped me tremendously in completing this study and share our results with the rest of the world. After my time as a research fellow at the Brigham and Women's Hospital in Boston, I moved back to Europe, and in 2018 I was appointed head of Skin Cancer Research Center here at the Technical University of Munich. We treat all different kinds of skin cancers, but melanoma remains one of our biggest challenges. This is why my research team and I work on several, mainly translational research topics that aim to further improving treatment options for melanoma patients. In this context, I believe that there is much to be learned from looking at the very start of melanoma genesis. Wouldn't it be great if we could prevent the majority of melanomas before they even become a problem, before we even have to use fancy, sophisticated treatments? My model system for studying melanoma genesis is the so-called nevus-associated melanoma. There are melanomas, these are melanomas that arise in pre-existing moles that did not change for decades, for example, but all of a sudden start to give rise to a melanoma. This kind of melanoma makes up about 30% of all cases. The other 60% are so-called de novo melanomas and develop on previously unremarkable skin. And there is a very small group that develops on tissues that are probably representing a very different kind of melanoma altogether, like mucosal melanomas or uveal melanomas. Today we understand that melanoma is just not one disease, but it's many different types of diseases. And we're only starting to distinguish and comprehend all the different types of melanomas with sometimes very different biological trajectories. What we're seeing in these nevus-associated melanomas is that a fundamental mechanism that protects cells from turning cancerous after genetic insult, like an oncogenic mutation, is bypassed. This protective mechanism is called senescence. Some of you now might say, well, wait a second, senescence is not a good thing. And generally, I would agree with you if we are talking about the context in normal cells. Here, senescence can be a major driver of tissue and organ aging, frailty, and also disease. However, sending cells into senescence can also be a good thing if it means to stop a cell from uncontrolled growth. This type of senescence, so-called oncogene-induced senescence, is very powerful, but in some cases, as you guessed it, like in nevus-associated melanomas, this protective mechanism fails and cells escape senescence programs. My lab is now trying to understand this process of senescence escape with the goal to get new insights into the biology of early melanoma development. I hope that our research will open up new avenues for melanoma prevention and also melanoma treatment. And I'm very happy to update you on our progress in the future. For now, I would like to thank you again for your support, for your voluntary work, for your Outrun the Sun runs, and all your campaigns and activities. I think this is just wonderful and highlights that we can achieve a lot when we all work together and trying to keep our skin safe and healthy. So keep up the good work. We'll do the same here, and I hope to see you soon at one of the Outrun the Sun events. Cheers.